Hello students, welcome to section 2.4. Let me get this started for you. This one we'll continue with our work on sets, and particularly these are going to be survey problems, which are specific types of problems involving Venn diagrams where you use them to, of course, come to an answer. And like we went over in section 2.3, the best way to do it is to work from the innermost group to the outermost group. And I recommend to do it in parts. If you try to do a lot of these problems all at once, it's just going to become very confusing. So, let's look at a couple. Jump back up here. So let's consider the universal set from 1 to 9, where A is 1, 3, 4, 5, B is 1, 2, 4, 7, 8, and C is 2, 3, 4, 6, 7, 9, as you can see. Here's a question. What is A union B? A union with B union C. Now, like last section, a bit of review. What I recommend is analyze the parentheses first. So what we'll do is, what is B union C? That is 1, 2, 3. That's 1, 2, 3, 4, 6, 7, 8, 9. Now we'll take that and find what's the union of that with set A. Set A again is 1, 3, 4, 5. And that's going to be all the numbers from 1 through 9. And again, remember we said with the union, we don't need to put repeats even if there are any. You only need to write a number one time. So in the same sets, now let's do A prime intersection with B intersection C prime, and then the complement of that set. A prime, we can get already. A is 1, 3, 4, 5. A prime is, of course, everything that's not in A, but in the universal, which is 2, 6, 7, 8, and 9. Now B intersection C prime, if you work that out, it's going to end up being 1 and 8, and when we take the complement of that, we're left with 2, 3, 4, 5, 6, 7, and 9. When we find that intersection, we're left with 2, 6, 7, and 9. Again, the idea is to work from the inside to the outside. And here again, if you want to apply De Morgan's laws and make the second part of that B prime union C, you can do that as well. Either way, in this case, you want to do the right side, that quantity first, before you find the intersection with A prime. Now back to Venn diagrams. So fill in the values for the Venn diagram as you can see here. Now, like the end of section 2.3, we have our different sections labeled, and I've put in one value in the middle at 7, and I've also provided this information. This is our cardinality, if you remember. The number of elements in the universal is 48. The number of elements in section A is 21, and the number of elements in section B, set B, is 29. And the question of this would be, again, just fill in the remaining values for the Venn diagram. In other words, if there are 7, it doesn't matter what it is, if there's 7 of this element in between A and B, then how many elements are just in A, how many elements are just in B, and then is there anything left over? And we get with this. And we come up with these numbers based off the information I gave you. If you look at the beginning, I said the number of elements in A is 21. That means the whole circle A is 21. That's 21 of whatever this is. And if 7 of that 21 is already in the middle, then what's left over in the remaining parts of A should be 14. So again, because 14 plus 7 is 21. And by the same logic, the remaining section in B, region 3, is going to have 22, because 22 plus 7 is 29, which is how many elements I said were in set B. So with problems like this, and you'll see these where you'll be given a Venn diagram that says fill in the Venn diagram, or you'll be given a word problem to fill in the Venn diagram, you want to find you want to find the middle part. Now with two sets, it's of course the intersection of the two. If it's 3 sets, which we'll do in a minute, it's the innermost section, and work from the inside to the outside, very much like we did with the numbered sets. Now, if you wonder where that 5 comes from, the overall number of elements in the universal is 48. So with if there's 48, let's see how much we have just in those first three sections. We have 14, 7, and 22. We add those up, it gives us 43, which means the difference is 5, and that's what we put on the outside. And that's how you calculate that. All the numbers added on the inside, subtract that from the universal. What's left over, if there's anything, goes on the outside of the two sets. So again, same type of problem. This time the universal has 60 elements, A is 26, B is 23, and there's 8 common. So put me on pause, give yourself a minute, and figure out what the remaining sections would be. Okay, if you've tried that, this is what you should be getting. 8 in the middle. Again, since A has 26 elements, 18 is what's left over in region 1. Since B has 23 elements, 15 is what's left over in region 3. The difference between those three numbers and then the universal of 60 is 19, so that goes on the outside. Now back to a three Venn diagram set. Now notice in this one the way I gave you the information. Of course, I gave you the universal, number of elements at A, B, C, and then I described it as the intersections. The intersections of A and B has 17 units. The intersection of A and C is 11, so on and so forth. Now remember when I said 3 Venn diagrams, what I told you to do was start from the very, very middle, which is right in the, and this should be up here, excuse me, which is right in section 5. So when there's 3 Venn diagrams and we're trying to figure out how many elements are in each individual part, you always go with the very, very middle first, which according to this is going to be this last one. Number of elements in A, intersection B, intersection C, which is 7. So we start with 7 in the middle. And what I recommend is to go from the outside. So if there's 7 in the middle here, start working out. And the way I've given to you this is work up. B intersection C has 8 elements. So B intersection C is next to it. This is section 6. If that whole area in between those two sets has 8 and there's already 7 in the first section, the difference is 1. If I keep going up, now A intersection C has 11 units. A intersection C, of course, this includes section 4. If that whole region, that includes the 4 and the 7, has 11 units, and the 7 in the other section, that means the difference is 4. And just keep on going up. So I'll give you, so put me on pause, take a minute, see if you can figure out the rest of these regions. Okay, if you've given it a try, let's finish these. So if there's 17 between A and B, that means we'll have 10 remaining. Let me make that a little bigger. If there are, now let's start with set B, just because B has 21 elements. In all of B I already have 10, 7, and 1, that's 18, for a difference of 3. In set A, I have 26 elements. Already with these sets I have 10, 7, and 4, which gives me 21. It's 26 total, the difference then being 5. Next set C has 18. I already have 7, 4, and 1. 12. If there are down here 18 elements in C and I already have 12, then the difference is going to be 6. Now we want to see if this comes out to our grand total of 38. If it doesn't, anything that's missing will go on the outside in section 8, as you can see here. So if we add up all of our numbers, let me do it right over here. I'm just going to add up 5 plus 10 plus 7 plus 4 plus 1 plus 3 plus 6. And that should come out to be 36. And if that's 36, then, and there's 38 in the universal, that means the difference is 2, which goes out here. So this is what you should have for your final layout. And that's what I'd be expecting on any test or quiz, or problems comparable. Now, when you take a quiz on MyMathLab, what will most likely happen is they'll have you fill in just the numbers. Instead of in the Venn diagram, they'll represent the sections and have you fill them in. Finally, we have a word problem, which is essentially the same thing. This time it's the same problem as what we just did, except now we're given information in terms of words. We have to interpret this. Dean of academic students surveyed a group of students about which support services they were using to help them improve their academic performance, and they found this. 5 were using office hours, tutoring, and online study groups. 16 were using hours and tutoring. 28 were using tutoring. 14 were using tutoring and online study, and so on and so forth. And it's important to look at some of this wording. 8 were using office hours and online study, but not tutoring. So what this is doing is we're singling out sections. So how many students were surveyed, how many students were using only office hours, and how many students were using online study groups. You want to make 3 groups here. Office hours, online, and then regular study groups. As you can see I did here, or tutoring is what I used. And as you can see from the information, I had 3 groups, so I said what's going to be the combination of all 3? What represents using all 3 of them? So is there a stat that tells me all 3 were used, and that's the first one. 5 were using office hours, tutoring, and online study groups, so all 3. So 5 goes in the middle. And with these, that's where we start. Now we'll just keep going on the outside. Let's see if there's anything for online and then just regular tutoring. Was there a stat for online and tutoring? Let's see. Okay, it says 14 were using tutoring and online study groups. So, if 14 were using tutoring and online, that's this middle section here. We already had a 5, so if 14 total, that means 9 is the difference, which is why we have 9 there. Let's look at office and tutoring. Do anything related to that? Office hours and tutoring. Oh, 16 looks like. So I go back down, and if there's already 5 in here, 16 is the difference. That means we have 11. Excuse me, 16 is total. That means 11 is the difference. Online is the online and office hours. Is there a stat for that? So there's office hours and online study, but not tutoring. So online and office. Now this time they state specifically not tutoring. So we can rule out that this 5 was part of that group. So we can just stick 8 directly in between there. And the rest follows like the previous questions. So this concludes section 2.4. As always, if you have any questions on the way this is laid out, how we do these problems, feel free to contact me, and have a good day.